Because atoms contain electrons that are wave-like in nature. That is, electrons of atoms cannot stay at a place. They are wave-like. They move like waves. They form clouds. They are cloud-like. Because it happens like that, you cannot specifically determine where an atom is at a particular place. You can't determine the speed and the position of an atom simultaneously. This is according to Heisenberg's uncertainty principle. So, this concept enables us to define an atomic orbital. An atomic orbital is just a region of space around an atom where there is high probability of locating an electron. What we mean is that you can't, like in SS1, you see the teacher drawing an atom like this and placing electrons this way. This is just the elementary aspect of atomic studies. But in real sense, electrons cannot stay at a place. Electrons are just wave-like, which means a single electron can form a cloud-like something. Meanwhile, you can pick an electron at a place within a framework of time. This electron can be here, it can be here, it can be here, it can be here, and it keeps moving like wave. So this wave-like nature of electron enables us to define what an atomic orbital is. And in elementary chemistry, electrons exist on atomic shells, energy levels. But in real sense, these energy levels are made up of orbitals, where you can determine where the electron is, where the electron exists. It's not actually in the shells, it is actually in orbitals. And these orbitals are a region around the atom where there is high probability of catching an electron. Let me just use the word catching. Now, since atomic orbitals exist in space, it has shapes. It has shapes. So let's examine the 4 orbitals we have. Types of atomic orbitals. 1 is S orbital. 2 is p orbital. 3 is d orbital. And 4 is f orbital. These orbitals have different energies. S has smallest energy and it contains maximum number of 2 electrons. P contains maximum number of 6, D 10, and F 14. Now we are trying to look at the shapes of these 4 orbitals. The electrons in S orbital, either 1 or 2, because the maximum is 2, they vibrate because it's wave-like. Electron is wave-like. The electrons vibrate, producing a spherical shape. Therefore, S orbital is spherical. This spherical shape is found around the 3 axes of the space. This is how to represent space. This is 0. This is x-axis plus x. This is minus x. This is plus y, and this is minus y, and this is plus z, and this is minus z. These x and z are planar. They are planar, meaning that they lie on a plane. While y, this negative y is pointing towards you. The positive y, okay, let's say positive y is pointing towards you, and negative y is pointing inside the whiteboard. So you can now see how the space is represented. So for s orbital, if this is s orbital, the electron in s orbital vibrates, producing a spherical shape around the 3 axes of the space. So this is the shape of s orbital. This is the shape. P orbitals are degenerate. That is, we have 3 types of p orbitals: px, py, and pz. Px orbital, the shape x, y, z. Px here means that, let's just call the shape of p orbital. P orbital has this shape. This is the shape. The electrons in p orbital vibrate, producing this shape, and this shape is called dumbbell. Dumbbell shape. Now, the orientation of the dumbbell shape determines the kind of p orbital. If the dumbbell shape lie along the x-axis, it means that this is px orbital, because the electrons vibrate, producing a dumbbell shape that lie along the x-axis of the space. Now, you can imagine the shape of py orbital. It means that the dumbbell shape lies along the y-axis. So this is the shape of py orbital. These are the possible positions of the electrons around the shape. So this is Py. So by now, you will be able to draw Pz orbital. That is Pz. You know that the dumbbell shape lies along Z. So this is the shape of Pz orbital. D orbitals are degenerate also. There are 5 D orbitals. dxy orbital, dxz orbital, dyz orbital, dz square orbital, and dx square bar y square orbital. There are 5 orbitals in D. So let's examine the shapes. So what I've just done is to write to draw the space where I will draw the 5D orbitals, the shapes of 5D orbitals. So let's take the first shape. Let's draw dxy orbital on this shape. But before we go on, we would like to examine the shape of D orbital. The shape is like this. This is the shape, which means electrons in D orbitals vibrate, producing this shape. And what is the shape? You could see that this is 2 dumbbell shapes. So you can call it double dumbbelled shape. Or you can call it rosette shape. It's a rosette shape. Now, what does it mean? It means that D orbital has double dumbbell shape. One of the shapes will lie along one axis and the other one will lie along another axis or in between 2. Now, how do we determine dxy? If you look at xy, what is not in this xy is z, which means the first dumbbell will go to z. That is the concept, the logic in drawing it. First of all, check the alphabets xy. Y, x, y, z is not there, which means the first dumbbell goes to z this way. Now, second dumbbell will go in between x and y. So this is x axis and this is y axis. This is the in between. Put it there. So this is the shape of dxy orbital. The next we are trying to draw is dxz orbital. You can use the same logic. Xz, y is not there, so the first one goes to y. And the second one goes in between x and z. This is x, this is z, and this is the in between. This is dxz orbital. Now let's draw the next, dyz orbital. Yz, x is not there, so the first one goes to x. And second one in between y and z, like this. So this is dyz orbital, the shape. The next is dx square bar y square. This time around, the square there means you place it on x. X square, 1 goes to x, and y square, 1 goes to y. That is dx square bar y square. And finally, dz square. This time around, is only z square, which means 1 goes on z first. Then there is no y, there is no x, which means that the other one will just revolve around this first dumbbell shape, touching x and y, but not going in between x and y. It will touch x and y. So it goes like a tire around something like this, goes around like this. That is the second one. You could see that this second one is touching only x axis and y axis. It doesn't touch z. But the other one lies on z and passes in between this second one that goes around, touching y and x only. So this is the shape of dz square orbital. You can look at all the shapes. They are not the same. Their orientations are not the same, but they are the same rosette shape. Going to P, they are not also the same. This is PZ orbital, where the dumbbell lies along Z. This is PY orbital, where it lies along Y. This is PX, it lies along X. And this is S orbital, spherical, around the whole axis of the symmetry of the space. Now P has been drawn, D has been drawn. F orbital is more complex. It's too complex to draw. The shape is so complex. So at this level, we will only identify S orbital, B orbital, and D orbital. Do have a nice day.